Good morning, good afternoon, and good evening. Welcome to our DevDen office hours. I'm Grace Francisco, one of your hosts. Let me introduce you to some of my fellow co-hosts here. Ian Buchanan, say hello.
Hello.
And we've got Nicola Paolucci.
Hey, good morning.
Sorry if I butchered your last name,
Good
Nicola. We've got Mr. Steve Smith,
Hello.
Steve Smith. And then we have, of course, the lovely Tim Pedersen.
Good morning.
All right, guys. So today we're talking all things Git. So the team here, and actually before we get going, if you would like to ask us questions at any point in time, make sure to use that Q&A panel that's on the left-hand side there and ask us at any moment that you feel, and we'll pick those questions as we go. So first up, we just finished a tour, which we call the Getting Git Right Tour, and the team just came back from Europe and North America. Let's just chat a little bit about what we found from these tours. What's your takeaways, guys? Nicola and Steve, you guys covered Europe. What did you notice about the developer communities there?
So it was very interesting because every time we're on the road, you notice that there's a big difference in adoption and changing between city by city or country by country. So one of the surprising things was in Helsinki, everyone seemed to be already moved to Git for a couple of years, and so we had much more advanced conversations than we usually do. And while in Copenhagen, it looks like the market of teams, corporate teams and bigger teams moving to Git was just hitting the right spot, and a lot of people were keen to know a bit of the intricacies of moving teams to Git, and so it was very interesting for me to notice that not everyone everywhere in the world is already on the bandwagon. And there's very differences in the stage of adoption. What surprised me in Milan from the Milan stuff was that about half of the people were already used when I asked were there, which was very interesting to me. So it means even my fellow Italians are basically keeping up with this major trend. That was one of the things I noticed. What about you?
Yeah, absolutely, very much the same. There's different levels of adoption, so you get different questions, and we are going to recap some of the good questions we got. So some people are asking about how you migrate and how you would deal with different situations. Some people have already started to migrate and are hitting little hiccups, or want some clarification, or little things like how to why certain things happen in Git that are different from Subversion, or tricky repositories that need to be migrated. So little problems, so you sort of see how much migration had occurred in a given place by the sort of questions you got. It was kind of fun to sort of talk to people and have like different real-world issues and experiences coming back from in different levels from different places. But it was a very fun tour. It's very, very fast, but very, very cool. Lots of really good energy and excitement around Git right now.
Great. Tim and Ian, you guys just came back from the North America tour. Tell us a little bit about how that might be different from what happened in Europe.
Yeah, it was interesting, actually. It was kind of a similar experience. So we hit Seattle, San Diego, Vancouver, and then Ian went on to Montreal as well. And it was really interesting to see the different kind of levels of technology adoption and process adoption in the different cities. Seattle really stood out as a big tech town. I mean, you've got Amazon and Microsoft and Starbucks there. And almost everybody in the audience was already using Git. I think there were one or two hands that didn't come up when we asked who already migrated to Git. We also polled the audience a couple of times asking about different developer processes that they use. In Seattle, there was maybe 70% using continuous integration and about 40% doing code review, typically through pull requests. Because as I mentioned before, everyone was already using Git. This was much higher than the other cities we saw. In San Diego and Vancouver, it's probably maybe 40 to 50% were using some sort of continuous integration, and maybe far less were using code review, probably maybe 20 to 30%. Which makes me think that there are probably a lot of people out there using Git, but potentially not using branches and pull requests for doing development.
I think one of the things that I saw in the audience is, as I was polling for how long people were using Git, is that many people were not using Git for much longer than a year. And so many of the practices that they had were still carrying over from Subversion days. And so much of the content that we were talking about in terms of branching and the merge strategies was really applicable for them so that they could keep adopting better Git practices.
Super. And before we go on to like some of the questions that you guys were getting, I know that there's been a new release of Git 2.2.0. What's new with that release? Can you guys kind of share that with the audience?
Oh yeah, Git 2.2.0 is huge. There was a bunch of new features and regular performance improvements and some nice improvements to make kind of the Git onboarding experience better. So one example is they made Git config learn some sensible defaults, so it'll actually automatically generate your username and email based on your current system setup, which is really handy. There are also a couple of workflow improvements. Git stash list in particular learned how to display patches. If you haven't heard of the Git stash command, it's a super nice thing that Git offers over other version control systems. Lets you switch context really quickly, so you can switch up your workspace quite fast. But what I'm really excited about in Git 2.2.0 is actually signed pushes. So if you're not familiar with signing in Git, there's a bit of a myth with DVCS where people are concerned about having all of these different copies of repositories everywhere, and the fact that you can override author and commit metadata locally, that there's a security problem because potentially people can spoof commits. But it actually has this really powerful and flexible security system called signing, where you can use a GPG key to sign your commits to basically authenticate that you're the person that created it. And Git has supported signing tags and commits for a long time, but Git 2.2.0 actually brings signed pushes to the table as well, which means you can actually guarantee that the person who pushed a particular branch or updated a ref, so a tag or a branch, is the person that they say they are. So if you're working in an environment where security is very important, like the finance industry or biomed or banking or government, then this could be a big win and potentially one of the last hurdles that need to be overcome before you can adopt Git in your organization.
So one of the things that's really exciting for me is that in a previous life I was working with open source integrations and wanted to publish the source code for those as well as binaries. So we got to using the Git archive command. In the 2.2 release, there's now support for
handle binary files with Git.
And sorry, Nicola, it looks like we somehow magically got muted, and so I've unmuted you. Can you just go through that one more time for the audience?
No problem,
Sorry about that.
No problem. So then the question was, which recurring questions we get on tour, which questions were interesting, and I mentioned that I often get like a top 3, top 4 of very similar questions, and one very common one is how do you handle binary formats, big binary files when you use Git? Unfortunately, there's no silver bullet that will solve all people's problems related to this. So what I try to give is some pointers to try to tackle that issue. The first answer I always give is, if you can, do not store binary files in Git. That's the so if you can find an alternative way to store and tear your code with binary files, you should investigate them. So an alternative to that is trying to use one. There's a couple of tools that lay on top of Git, which have tried to tackle this complex problem. One fairly popular one is called the Git Annex, that allows you to store all your binary assets somewhere on a shared drive and only link the metadata related to the versions of the files into your Git repository. So that is one of the ways. Another way, which is slightly suboptimal but could be a choice for some people, is separating your binary assets into a submodule, and this way you allow your code developers that don't need access to the freshest and latest versions of the binary assets to work independently in a bit more flexible and fast way, while people that need to build those big assets and work on them, then they can have full burden of handling the binary files. And there's a few other ways and a few other toggles that you can put in place, like creating a custom merge strategy that will allow you to do proper diffs and merges of your proprietary file formats. I've written a little bit about it on the blogs.atlassian.com. That's one. Another common one I get all the time is how do you handle dependencies between modules when using Git. I wrote extensively about that, and our answer is trying to use a dependency management tool like Maven or Bower or Bundler. So whichever your tech stack, you are much better off using solid solution that does dependency management than using Git with some modules or subtrays, which can get clunky quite quickly. They want to take all the airtime. So those were just a couple. I don't know if you guys have other recurring things that came up.
What about you, Steve?
Hi. Yes. So one of my favorites, or some of the favorite ones that came from me on tour, was on the most recent tour. We started to introduce some, to the low-level concepts, the fundamental building blocks of Git. So we found that by understanding those fundamental building blocks, which are very few and very simple at its core, Git is actually very simple conceptually. But if you understand those core concepts, a lot of things that are difficult and confusing about Git suddenly become very simple. So people come to me with little tricky little problems, particularly when things like cherry picking versus rebasing versus merging, and what exactly happens. Even me and Nicola, when we're bouncing ideas back and forth at work, you kind of go back, okay, let's look at the conceptual model. How does it fit together? Oh, right, of course, there's no actual merge because it recognizes that by the common ancestor, or, oh, the parent changed, therefore the hash changed. Little things like that. So it's more than we go into in this talk like this, but do check out some of the videos from the Getting Git Right tour, or the presentations. They should be available online. Cover some of the conceptual ideas around it, because it's fun to talk to people after they've heard this, and literally can sit there at them and go, oh, I get it now, and all these tricky little problems, things that were hard become obvious. So that was the coolest part for me.
Great. Ian and Tim, what kinds of things were you guys getting asked on the North America tour?
I actually got one of the most technical questions I've ever been asked at any event, particularly Getting Git Right, where there was a gentleman who'd evaluated Git a few years ago, but had some troubles with performance with very large change sets, very large commits, where basically you'd end up having like a large number of paths were being modified in the same commit, which is a bit of an anti-pattern, but besides the point, Git wasn't really working out for his workflow, because of an interesting way that the Git index is structured. It's basically, well, it used to be a single file that just sits in your .git directory tracking all of the paths that have been changed. And if you have a very large set of paths that have been modified, Git actually has to rewrite that index every time you make a modification, which can be a big performance problem. And it's actually something that changed in Git 2.1, where they built a new experimental index format, where it creates a, well, again, a monolithic index file, but then rather than rewriting that entire file when you make changes over a certain size, it actually creates a bunch of delta files which apply to that one. So it was really nice to get that question and be able to say, yes, actually Git 2.1 has potentially solved that problem for you. It's still experimental, but it's really cool to see that the Git core team are continually working on performance improvements like this and thinking about all of those edge cases to improve Git support for different team workflows.
Cool. Ian?
I'm sure one of the things that all of us must have heard several times, since we had parts of the presentation that focused on how Stash adds some value over Git itself. A lot of people wanted to know what's the difference between Bitbucket and Stash, especially with regard to the integration with Jira and Build, as we were demonstrating. And I think pretty much the simple story is that Bitbucket is in the cloud and is a hosted solution, and Stash is a behind the firewall on-premise solution, and that for the purposes of the integration that we've seen, we're pretty much on parity there. And over time, we expect that any feature differences that people have noticed would converge, and so it's really the difference in deployment models.
Great. Tim and Steve, you guys just wrapped up a couple of webinars. You guys want to give us a little bit of an update on what you guys talked about, starting with Steve, and some of the outcome of that webinar?
Yep, absolutely. So the webinar was really about Stash and Bamboo and about the integrations inherent in that we now have enabled in Stash and Bamboo. And it's really this idea of a feedback loop. So, for instance, Stash will feed forward information into Bamboo and help it make coherent decisions and create new branch plans and generally do a lot of things for you. In return, Bamboo talks back to Stash and gives a lot of information and metadata about the state of builds. In particular, are tests passing, do you have coverage, things like that, can be passed back into Stash. So when you're doing pull requests, you can use that information to automate a lot of things. Pull requests and code reviews are a credible tool. I blogged about this recently, about how we adopted it on the internal systems team for really our own good, rather than some sort of mandate from management or something like that. But it's a more work intensive. So by using Bamboo's data to feed back into Stash, you can get Stash to do a lot of the work for you and warn you about potential problems in a pull request without having to manually inspect or short circuit some of the problems you might find. So some of the questions, some questions came out as well. We can sort of talk about a few of them here for today. So a lot of it's about can you, Almost Classic was for us was Jenkins, and we got this a lot on the tour, and we got this in the webinar as well. Comparison to Jenkins. I don't want to do a sort of feature by feature comparison, but one thing that worked was important for us on the internal systems of the business development team is we are a finance system. We have strict requirements regarding how code is deployed, and particularly separation of duties concept that says that only the people who are building the systems or producing the build plans cannot be the people who are releasing the code at the end of the day. Developers cannot release the code. There must be a separation of duties. In Bamboo has first-class support for this kind of fine-grained permission and workflows, and this concept of deployment environments. It understands that you have a development environment, a production environment, a staging environment. You might need different rules regarding who can deploy to where, and Bamboo has first-class support for that. And that's one of the major reasons why, but obviously we went for Bamboo because it's ours. But at the end of the day, that really solved a lot of problems for us and made life a lot easier during the migration to a continuous deployment pipeline. Tim, any thoughts?
Yeah. Oh, in terms of Jira and Bamboo, there was a couple of other webinars that I ran as well, which I might just recap quickly. There was one a couple of months ago where I just spoke about Git workflows specifically used by SaaS teams. We covered a whole bunch of different topics, focusing on, well, first of all, why you might use Git for developing SaaS in the first place. We talked a little bit about what makes a SaaS workflow different from a traditional application development workflow. And we also talked a little bit about the merge strategies and pull request workflows that you use inside Atlassian and how you can apply continuous integration and continuous deployment techniques with Git to get the most out of your SaaS workflow. I'll post a link to that webinar in just a second. But more recently, I did a second webinar on Jira and Stash integration, showing some of the awesome stuff that the Atlassian Fusion team, which is the team working on building integrations between our various products, has built on top of Jira and Stash. One of these is the Jira development panel that came out last year, which gives you all of the context of your development work inside Jira, which is a really convenient way of getting more context about a particular issue. More recently, in Jira 6.3.3, we released automatic issue transitioning, which is a godsend for product managers. Basically, it means that developers no longer have to keep their Jira issues up to date. Instead, they'll be automatically updated from Stash whenever a developer makes a change to their repository. But the main reason I put together that webinar was to show off a new feature that's coming out early next year in Jira 6.4, which if you haven't heard of it yet, is the version tab panel. And what's really cool about the tab panel is it actually makes the release process easier by showing you potential problems with your upcoming release. In fact, I might just see if I can share my screen and give you a quick example of what that's going to look like. Bear with me, I'm just fairly new to this Google Hangout thing. Here we go. Oh, wait, actually. So this is just a couple of screen grabs from the webinar, but basically the new version tab panel, which is currently live in Jira On Demand and also available in Behind the Firewall if you enable a certain feature flag. I'll tweet out exactly what that flag is in a moment. But inside Jira, you now have the context of all of your development artifacts related to a particular release. So you can see here we've got a couple of warnings that it's giving us. The first is that there's a failing build associated with an issue, which potentially shows you that if you perform a release at this moment, you might be shipping a buggy product to your customers. So this is a super important insight into your code that would potentially be hard to figure out otherwise. We also have some other kind of deeper integrations here, like we can see that there's a couple of issues that are marked as closed, but actually have some unreviewed code in there. And because we are big believers in pull requests, typically every line of code is checked by at least 2 other developers at Atlassian before it gets shipped to our customers. So again, that's something we want to address before we ship it to our customers. So that's coming up in Jira 6.4. So if you are into automating workflow and getting more insight into your release process, I highly recommend checking that out. There were quite a well-attended webinar, and there are quite a few questions that we got, which I unfortunately didn't have enough time to answer during the webinar itself. So I'm currently writing a recap blog on that. But just to cover a couple now, just grab I have a few questions here. Oh yeah, so one of the biggest questions that I got is that people love the idea of the Stash and Jira integration, but they're wondering whether it's possible to integrate other issue trackers into Stash and get that same Jira experience, and whether you could do the reverse and integrate other repository hosts into Jira. So if you're using something else to integrate your Git repositories. And the answer is kind of a yes and no. Both Stash and Jira have very in-depth plugin systems. It's been kind of one of our development philosophies at Atlassian for a long time to make sure all of our products are as extensible as possible so you can customize them to suit your workflow. So theoretically, you could integrate other issue trackers into Stash and other repository hosts into Jira. However, the depth of the integration that we have between the two of them is something that's taken our Fusion team a significant amount of time and investment to build. So while you can integrate other products into the workflow to get that same experience, it might be, it would be a significant investment. So something that you should evaluate carefully, possibly before jumping into. Another good question that I got from that particular webinar was whether it's possible to distribute Git commit hooks with Stash. And this is a question that's actually come up at Getting Git Right a couple of times as well, because we do talk a little bit about commit hooks, which are basically the plugin system for Git. And commit hooks are a bit of not a problem, but something that doesn't have a really good solution as yet, because commit hooks are things that developers have to install locally in their own repositories, and being a distributed version control system, there's no way that you as an administrator or a team lead can enforce that your developers are running certain commit hooks. But in terms of distributing and syndicating hooks, the best solution that we've come up with at Atlassian is actually check those hooks into your repository, and then basically symlink them into your Git hooks directory. And that seems to, we've tried a few different approaches, like attaching them to project pages, wiki pages, and putting them into our developer guides and things. But that simple concept of just putting them in the repository means that they get syndicated with the repository, and the only manual step your developer has to do is just symlink it into their hooks directory. And that seems to be the most practical way we've come to approach that particular problem.
If I may interject, if you don't trust that people are going to actually stimulate them by themselves, you just tie it to your maven build commands or to your build commands so that they check that the links exist. So that that can enforce it like out of the box without having to go and check on every developer's desks.
Nice.
So.
Absolutely, yeah, and as well, another step is to any commit hook that is kind of vital to your build process, you should absolutely enforce that on the server as well in a pre-receive or an update hook. You shouldn't rely on people quite often write lint tests and check style tests to run locally as part of a commit hook, but that should always be a convenience thing rather than an actual enforcement of the policies that you apply to your build.
You're still sharing your screen, by the way.
Super. Steve, you want to talk a little bit more about the webinar you ran and some of the questions that you were asked?
Yep, absolutely. So another one that came up, this again comes back to permissions, is a lot of things about questions about can pull requests be approved by a member of the group? Can you basically have separate groups of people who are allowed to approve pull requests versus people who are submitting pull requests or creating branches? Another one that came up is, can you control lock a master branch at regular intervals during a release critical period? The answer, of course, is yes. This is really what Stash delivers above and on top of Git. Git doesn't really have much of a permissions concept in and of itself. It has a couple of really cool things like that Tim mentioned, like signing and so on, but they're really sort of a way of authenticating history. But in terms of on a day-to-day workflow basis, there's no real concept that committer A can only commit to branch A, and so only certain people can merge to the master. This is where Stash really comes in and really adds this layer of authentication and permissions on top of the Git workflow, which again is one of those things that the open source world does not need so much. It works slightly differently, but enterprise really needs these sort of slightly different and more controlled workflows in many cases. So that's pretty much it. Anything, if you need complex permission systems, you need something that layers on top of Git that provides an extra layer of management. And of course, I would recommend Stash for that.
Great. So, guys, tell me what a couple of things. What else is coming up in Git, and if you were to have a crystal ball, what would you predict might come out of Git in the future?
It's an interesting question. I mean, one of the things that seems to come out in every Git release is performance improvements, which I think is fantastic, particularly since Git have obviously dominated the market in terms of fast version control. It's kind of one of their biggest things, performance as a feature. But it's great to see that they are continuing to build out that performance, improve the way that they store data on disk and the way that they improve their indexing performance and tweak protocols, always in a backwards compatible way, of course. But so if I was going to make one prediction, I would guess that Git is going to get faster. It's also interesting if you follow the Git mailing list, they're very militant on making sure that new features that get written don't affect the existing performance. So another prediction, I guess, or an anti-prediction is that Git is not one of those things that's going to end up with feature bloat. It's anything that does get added typically goes through a very stringent quality control process, and there's always a lot of discussion around whether we actually need this particular feature on. So yes, I expect it's going to get faster and faster.
Super.
Just a very recent thing that I saw, it's not specifically related to Git roadmap, but was very interesting, is one of our colleagues, Stefan Sassen, who's architect on the Stash team, spent a few weekends rewriting the entire Git clone command in Haskell. So he has this really long, like 13,000 words article where he breaks down how Git stores data and rebuilt it from scratch using Haskell. And it was yesterday in Hacker News, funnily enough, because it's actually a year-old article. But I found it very interesting. So we just in the last Getting Git Right tour, as Steve was mentioning, we wanted to give people a sense of the data structures, the low-level data structures of Git, because once you understand the low-level data structures, you have a much clearer picture of what's happening. And so if you guys are interested into having a really deep dive in how it generates the pack files and how the networking protocols, and it's a very interesting read. You don't really need to know a lot about Haskell because to follow that article. It will give you a lot of insight into low-level mechanics of the. There you go. I see. Tim has already posted the link in the chat, so you guys are encouraged to check that one.
To even expand a little bit more on that, one of the questions that comes up occasionally, you see on Stack Overflow, and we have this conversation sometimes even inside the company, is like, you're learning a new language, what do? You want to learn the language, but you don't quite know what you're going to do. I used to say BitTorrent, as in I don't mean a full BitTorrent client, I mean just the BitTorrent file, being able to read and parse and write a BitTorrent file, because it's one of the things the spec can fit in your head. You don't need to go and re-examine the spec every time. It's really simple file format. Nowadays, if somebody asked me that, I would say Git. You don't need to do the full network stuff, and the pack file is a bit of a complex idea, but the core concept of Git, you can write something that reads and writes a Git repository in a few days, in a weekend, and it teaches you a lot about language, and the Git spec fits in your head. Once you understand it, it's very, very powerful. So I basically did a basic Clojure implementation. You know, Clojure is a Lisp on the JVM, very, very cool. I used that a Git implementation, very quick, just reads a repository, writes a repository, writes some files, and it's really about a page or so of code, and it's a great way to learn a new language if you're trying something out. It's a great way also to internalize Git. As I say, once you internalize Git, it becomes a very, very natural way to work, and you realize the full power of it.
Yeah, absolutely agree with that. There's one of those sort of light bulbs that goes on after you've been working with Git for a little while, and then you sort of read an article about the DAG, or the directed acyclic graph, that is kind of the core Git data model, and then you're like, oh my god, everything makes sense. And all these commands you've been using for so long and kind of like struggling with, like git reset, git rebase, git cherry pick, like all of those can be described as operations on that DAG, and it just makes everything a lot easier. I've just posted a couple of articles. There's one called Git for Computer Scientists, which I really recommend, and another one from Scott Chacon's book on ProGit, which he's just written a new release of. He's got a great section on Git internals, which talks about kind of Git from the plumbing layer all the way up to the porcelain layer, and explains how all of those everyday commands that you're using with Git actually operate. So if you haven't read those yet, it'll take you a couple of hours, and it'll change the way that you look at Git as a version control system, and make your experience much more pleasurable.
But if you guys are interested and know what you guys think, get questions, I could share the slides of this 5-minute deep dive into the Git data structures.
That's a great idea. Yeah, for sure. Man.
Absolutely. Yeah, so let's do it. I'll try to share the screen as well. See if it works. So this comes from. All right, you should be able to see. So this is one of the slides we've been sharing during the Getting Git Right tour. And if you just memorize this, you will get easy understanding of some of the low-level concepts of Git. So I don't know how you guys want to do it, but maybe when you initialize, let's do it like this. Can you guys see my command line now?
Yeah.
I think so. Cool. So when you initialize a Git repository, Git basically generates just a couple of empty folders. And if you start adding, say, a text file to the index ready to be committed, what Git does, it compresses the file, generates a unique ID for it, and uses the first two letters of the generated SHA-1 cryptographic hash as a folder, so that it can spread the files across multiple folders, and that's it. Compressed, gives it a unique ID, and then done. And once you then commit this change to your repository, Git creates. You end up having 3 objects. One is the blob that represents the piece of content you just added. The other data structure is the tree, which represents the content of a folder with all its pieces of content, and it's a recursive data structure, so its tree can point to other trees. And then in the end, the commit object points to a tree object. So it's very basic, very, very simple, but this simplicity actually allows for great power. So if you go back to the chart I was showing you, you'll see that there's a Git indexes content. It doesn't really track files, even though it stores the file names as metadata in the tree object. That's not the core. I mean, Git actually handles blobs of content, tracks blobs of content. And the way that then the history is preserved is by chaining commits. So every commit object has a reference to its parent, and this is how Git creates this chain of commits. And with this very simple concept, you get all the flexibility and the power of Git. And maybe I'll stop here, otherwise I'll show you a few more things. So that's a very quick, high-level description of.
So Git, as you know, is a very powerful tool, as Nicola was just talking about. But that same powerful tool can actually also rapidly get someone into trouble quickly. Can we talk a little bit about what you guys have been hearing about, like, the biggest issues in terms of adoption and barriers to entry for actually picking up Git in an organization? What you guys would recommend in terms of overcoming some of those challenges?
Yeah, so there's one thing, I don't know if you guys you can interject. I'll tell you a story of a guy that came to me in Helsinki. And he said, we were convinced, we read a lot about Git, we decided to start to completely go with a new project using Git. It's a big 8-person team, well, big. It's an 8-person team, and we didn't know Git at all, and we started using it, and we were using Subversion before. And we had a terrible time. Nothing worked. We spent hours trying to understand why things weren't working. The history was always corrupted. And so what they ended up doing is one of the recommendations that we give, but they had to struggle a month before they went back. So they went back using Git as a Subversion, using rebase and just a single branch master. If you use rebases and a single master branch, you basically replicate more or less how you have been working for many years, maybe with Subversion. And that's a reasonable first step to get everyone on a new platform and trying to understand all the new concepts, the new metaphors. Unfortunately, these guys try to jump head on into full Git distributed workflows and feature branch development. And if you don't train your team, and if you don't have somebody who can act as a champion for this transition, you might run into trouble because the concepts are fairly different. So my recommendation to these guys, and also to people that are maybe in the phase of adopting Git, is start slow. Make sure you have a champion or somebody who is a bit more familiar with Git at the start. Maybe hold some brown bags and some tutorials, and create a cheat sheet for simple commands and simple flows of update, commit through the application. And then after a while, when people are acquainted with a simple procedure, you can start to adopt the other core practices of distributed version control, that is feature branching and code reviews using pull requests. And if you give it a span of a few months, you will be able to step by step adopt all the policies, all workflows, and then you will not go back afterwards. So, as in our experience, once the transition was made, even though there might be difficulties and some resistance at the beginning, no developer wants to go back after a few months. Once they've learned the power of feature branching, and so that's one thing.
Absolutely, yeah, and that's something that we've sort of thrown into a little while ago at Atlassian so Atlassian actually, shock horror, used to offer Subversion hosting as a product as part of our Jira on-demand suite. We decided after a little while that wasn't the best business model in the world. Subversion was kind of on decline, and also hosting Subversion repositories is a pretty painful business. So we actually ended up migrating all of our customers either to, we gave them an option. They could either migrate to Bitbucket, they could migrate to Git hosting locally in their own organization, or they could migrate to hosting Subversion locally in their own organization as well. So we gave them 3 options, but almost everybody took the opportunity to migrate to Git. So as part of that, we had to ramp up our Git migration expertise. So we've, a lot of the patterns that Nicola was just talking about, we've actually documented on our Git microsite. I've just posted a link in the chat, but if you go to Atlassian.com/git and have a look at the migration section, we've taken all of the patterns and tools and scripts that we use to migrate all of those customers, codified them so they're really easy to consume, and then put them on the site. So if you're one of those not a few people, there's still a significant number of Subversion users out there. If you are using Subversion and you're thinking about migrating to Git, definitely check it out.
Great. So one thing I often hear when we're out at shows and events is, you know, there are developers that sort of start playing around with Git and they fall in love with it right away, which is fantastic. But they're in a larger organization and they've got, you know, higher level executives or managers they've got to convince. What are the top things you would want to empower that developer with so that they can easily have that conversation with those leaders to get them to consider adopting Git in their organization?
Well, one thing that worked very strongly inside Atlassian was that we started using Git SVN, and the reason about Git SVN is basically it acts as a gateway. It will go off to your Subversion repository, pull it down. You can then work in a Git workflow locally, and only when you would normally do the commit to Subversion does it get pushed up to the Subversion repository. So you take a lot of advantages of the rebasing, cherry picking, all these complex workflows to clean up your history, and they only then push that up. Because as a developer, that requires no special permissions from anyone. And you can, this is how we kind of almost rolled out Git internally for many people. We started using Git SVN. People learned how to use Git natively without actually having to modify your core infrastructure or even your core workflows. So you could actually get your feet wet, without diving in the deep end. And then when the migration did come, it made life a lot easier. The developers had a bit more of the conceptual model. They knew the commands. You'll try and jump from a pure Subversion workflow, as Nicola mentioned, straight into a pure Git workflow with all features. You're probably going to have some confusion. But if you've been dabbling around the edges in a safe environment, getting some of the advantages of Git, but not necessarily having to go all the way in, you will find adoption occurs organically inside the company, and at that point, you can say, well, people are actually already using this. They already understand it. We can now start some test migrations with a little bit more confidence.
So in addition to that, which is it's a very nice, very smooth way to do the transition, is we always say is so our take is that adopting Git has a big economic advantage for companies, for software teams, because it allows you to release software faster and with higher quality. And the main reason for it is that you can split up new developments in isolated branches and only merge those changes back when they're done, tested, and reviewed. That means that your stable lines of code, your production branches stay stable, and you get less performance, less production issues, and you allow developers to work in parallel, in isolation, without downtime much more. And so this creates a speed of development that is very, very measurable. So those are just a couple of things that also make very sense economically from the budget perspective. So adopting Git makes shipping software faster and the quality higher. That's what we try to say when we try to sell to convince teams management to migrate to Git.
Absolutely, and there's one of our other Atlassians, relatively famous Atlassian actually, Sven Peters, who does a lot of traveling and speaking about development workflows and the way we do development at Atlassian, ran a couple of surveys at some Java conferences last year in 2013. I think it was, sorry, I have it here somewhere. Java Zone in Norway in September 2013, and Devox in Belgium in November 2013. And he asked a whole bunch of questions about developer workflows and Git adoption. And he came back with some really interesting quantitative results that suggest that Git is going to rapidly change the way that you do, improve dramatically the way that you do development at your organization. I might just share my screen quickly. I've got some slides from a presentation and I did at Summit last year, which kind of illustrate that quite nicely. So what we're looking at here is a graph of Git versus centralized version control versus release speed. What's really interesting to see here is that teams that release very rapidly, so people basically releasing their software every day, so likely SaaS teams where they're just doing a deploy to a service that they host on the internet, you're rapidly moving towards Git. I think this is probably because of the stability you can get in your release process if you use feature branching in Git, and also just for the speed of the tool itself. There was actually, and this is probably a little bit unrelated, well, actually, I guess it is related to Git adoption because we're really talking about pull requests. But another really interesting finding here was that teams implementing code review actually release faster as well. And the reason why I think this is kind of a super interesting result is because quite often one of the reasons that people don't adopt code review is because they think it's going to take too much time from the development team. So this is actually quite a counterintuitive result because we can see that people who are using code review, which is a process that takes a non-zero amount of time, are actually releasing faster. And again, I suspect this is SaaS services who need to make sure that when they do a release, the service is going to stay up. And the fact that they have other people improving the quality of that code by doing code review, probably lightweight code review through pull requests, means that they've chosen to adopt code review. So the results of that survey are something we're going to be writing up in the near future and publishing, but stay tuned for that.
Awesome. Well, we're almost out of time here, so I want to thank my co-hosts, or I'll say Ta in the local vernacular here, for helping and providing some great tips today on Git. And thank you for the audience for joining us. We'll be posting the recording of this shortly. And have a great week and good day from Sydney.
Good day.
Good day.
Good day.
Actually, just one little postscript. It appears that the links I've been posting are possibly not showing up in